Hello and welcome to the second part of the tutorial video of creating animations using LaTeX. I am Saptoshide. So in the part one of this video, I have shown how to create animation with pre-created frames, and I have also mentioned the disadvantages. And in this video, we will see how to create animations in a more systematic way, which I call the parametric way of making animations. We'll look into it how it is. So this is a very simple code of plotting a parabola using the LaTeX package called PGF plots. Um, Using that, I have drawn this parabola. Now suppose you are taking a class of parabola where you want to show the students how the parabola changes with the coefficient of x squared. So you see right now the curve that you can see here is y equals x squared. Now if you change it to 2, it becomes like this. If you change it to 3, it becomes like this. Okay, so you want to show the class in an animated form, that how it changes with the change of this coefficient. So how to do that? First we will start a new text file. We'll save it in the folder document, and again I will use the document class standalone for nice and clean output. The packages that we will need here is, we will not need GraphicX anymore, but we will need PGF plot since I am using this plot. It is also possible to parameterize drawings with LaTeX. So PGF plots we will need animate also, and we will start the document. The thing is, this drawing, whatever we have here, we have to call it as a function. So I will copy this code and I will paste it. What I have to do is I have to declare a new user defined function. So I will write a new command like this. So what is the command? Say I name the command as say parabola. You have to make sure that such a command does not already exist, and I have only one argument. Okay, only that coefficient is my argument. You can have a maximum of 9 arguments in a new command, and I will paste the code here. Now I have to pass the argument. So you see here, this is the coefficient that I want to change, and the first argument will come here. So I'm writing #1. If you have multiple arguments, you can call them by saying #1 #2 in the description of the new command. So this is the command. So first what we will do is that we will see whether this thing is working. So I will call parabola and I will pass the argument 5. So what will it give? So what it is now giving is the plot of y equals 5x squared. Okay, now we will create the animation. This kind of animation we have to make in an environment called begin animate inline. Okay, begin animate inline. So the first argument that we have, it is a frame rate. I will keep it say a slow frame rate 1. Now in this animate inline, now I have to call the function. So the function, so the command is multi-frame. Okay, number of frames. In our case, say I want to vary the coefficient from 1 to 10. So number of frames I will keep 10. Now variable. See here it is important how you write the name of the variable. Say I am varying it from 1 to 10 integer values. So I must start it with an I. Okay, then it must start with an I, so the software knows it is integer. If you want to give natural number, you have to give n, like that. So say equals, I am varying it from 1 and with a step of 1. So 1 plus 1 means starts with 1, varies with a step of 1. And what is the content? Now I will call the function parabola and I will pass the variable what I declared here. So what is happening here? I am calling this function. This is an user-defined function with one argument, and I am calling it, and I am passing the arguments one by one. What are the arguments? Which are defined by this. So it starts with 1 and increases by 1 in every step. So I will run it. Now we will see how it looks. Where is it? Okay, the same thing. I have to do the autoplay here. So I will write autoplay and loop. This thing I discussed in the part 1 video. Still not, no, it is running. So it is now changing. Now you can in this way have a visualization in the class that how it changes with the coefficient. Now suppose I want to have fractional change. Say I want to change from 1 to 10 but with a step of 0.5. So what I have to do is instead of I have to make it n. N is natural number. Say I will change with 0.5, so it will vary from 1 to 5 only, 10 frames. And this thing I also have to make n. So I run it once again, and this time it will change slowly like this. It is now changing from 1, 1.5 to 2.5 like that. Now I will show you the advantage of using this thing instead of the previous pre-prepared frames. Now suppose you want to have a change. Okay, you want to write also somewhere here what is the value of the coefficient so that students can relate. What you have to do is you have to simply change this user defined function. So I will just change add one more line in user defined function which will print the coefficient also. So draw, say I will write it somewhere here. So I will write say 1,17 at XCCS. That this means XCCS means, say I write 1,17. So 1,17 somewhere here it will write node. What will it write? I want to write k equals this value. Okay, so the argument itself will come here, and I run it once again. So you see it has come. You need not change all the 10. In this case it is only 10. You can even have 100 or 500 frames, just saying. In that case, it's in the pre-prepared frames you have to change all of them one by one, but here you need not change that. Change the value. See, it is jumping. That is because probably you will give an anchor, but anyway, that is the advantage of it, that you can change it very easily. All the frames you can change together, and you can have a visualization like this. One more thing to mention here is that you can have multiple such things in this animate inline environment. You can have another line of multi-frame. You can have another line of animate graphics to have an animation of pre-prepared frames. All of them, if you can stack together and you can show. So this is the most general way of making animation in LaTeX. Thanks for watching. That's all.